And welcome back to Applied Advanced Calculus. We are here at week 3 for Engineering 233. My name is Nathaniel Posesorsky. Let's get started. Today we're going to be looking at tangent planes. So for tangent planes, we want to get it into the equation A times x minus x naught plus b times y minus y naught plus c times z minus z naught equals to 0. But what am I supposed to do? Well, to start, we want to get it as f in terms of x, y, z. Then we want to do the gradient of that, substitute the point x naught, y naught, and z naught inside to get a vector of a, b, and c. And then finally plug it into the equation we mentioned before. Let's look at an example to better understand. So we have f in terms of x and y, which is equal to minus x squared minus 3xy, and we have the point 1, 2, 3. We know that z is equal to f in terms of x and y. If we move fxy to the left side, we get f in terms of xyz is equal to z minus f in terms of x and y, which is simply going to be z minus x squared minus 3xy. So in other words, z plus x squared plus 3xy. If we do the gradient afterwards, we get 2x plus 3y as the x component of the vector, 3x as the y component of the vector, and 1 as the z component of the vector, 1 being the derivative of z with respect to z. Then if we plug in the point 1, 2, 3, we get a vector of 8, 3, and 1. Finally, the 8, 3, and 1 represent a, b, and c, and the 1, 2, and 3 represent x naught, y naught, and z naught. If we plug those into the equation we had mentioned over here, we get 8 times x minus 1 plus 3 times y minus 2 plus 1 times z minus 3 is equal to 0. And finally, we get 8x plus 3y plus z is equal to 17. And that's the equation of the tangent plane. Now, to move on, we're going to look at how we calculate the curl of f. So, we're going to jump right ahead at the example. Yz for an x component, xz for the j component, and xy for the k component. If we're asked to find the curl of f for this f, we're going to do the cross product of the gradient times the f. Now the f, we're going to take the p over here and plug it in over here. The q over here, plug it in over here. And the r over here and plug it in over here. Finally, if we do the gradient cross the f, we're going to get x minus x, minus y, and then z minus z, which gives us a vector of 0. If the curl of f gives a vector that's equal to 0, well then f is conservative. That is a very important concept to understand because it comes up all the time in this course. They always ask you to check if something's conservative. Automatically, you need to do the curl of f and to check if it's equal to 0. All good? Also, it's very important to understand that the curl of f gives a vector. However, the divergence that we're going to look at now gives a scalar. So if we took xy for the x component plus yz for the j component and zx for the k component, this is our f. Now, if we're asked to find the divergence of this f, what we're going to do is we're going to do di p over di x plus di q over di y plus di r over di z. This p, q, and r convention stays throughout this entire course. P is always going to be what comes before the I, or the dx. Q is going to be what comes before the j, or the dy. And r is going to be what comes before the k, or the dz. So now, for the divergence, if we do di p over di x, plus di q over di y, plus dir over dz, we get y plus z plus x. As we could see, this is not a vector, it's a scalar. That's all, folks. We saw today tangent planes, curl of f, and divergence of f. If this helped, please leave a like and subscribe to the channel, and I'll see all of you in the next weekly video.